All right, so today let's break down machine learning. I mean, our goal here is to really just cut through the noise and get to what it actually is.
Yeah, and it's so important because this stuff, it isn't just theory anymore.
Not at all. It's everywhere.
It's in your streaming recommendations, the way your bank flags fraud, even self-driving cars. That's all ML.
And at its core, the idea is actually pretty straightforward, isn't it? It's about letting a computer learn from data itself.
Exactly. So you're not writing code for every single possible outcome.
You're just teaching it to see the pattern.
Right. I think the best analogy is the classic cat and dog problem. You don't program a computer with, the definition of whiskers or floppy ears.
That would be impossible.
It would. You just show it thousands of pictures that are already labeled cat or dog, and it learns the difference. It learns from experience, just like we do.
So that idea, learning from data, that kind of leads us to the three main ways this actually happens, right?
It does. And the first one, the most common, is called supervised learning.
Okay, supervised.
Think of it like a student with the teacher who has all the answers. The machine gets data that is already labeled with the correct output.
So the spam filter we mentioned earlier, that's a perfect example.
It is. You feed it a million emails that are already marked spam or not spam, and it learns what to look for.
But I guess that means it's only as good as the labels you give it, if there's human bias in the labels.
Then the machine learns that bias. That's a huge challenge in the field. But this supervised method is great for things like classification. Is this transaction fraud or not? And regression.
And regression is just when you're predicting a number, like a house price.
Exactly. Predicting a continuous value.
Okay, so that's with a teacher. What happens when you take the teacher out of the room? No labels.
Then you get unsupervised learning, and here the whole point is discovery. The machine gets a whole bunch of data with no labels, and its job is to find the hidden patterns all by itself.
That sounds incredibly useful for, say, a business trying to understand its customers.
It's one of the main uses. You don't tell the machine who the frequent buyers are. It finds that group on its own through a process called clustering.
So it just groups similar things, or in this case, similar people together.
Right. It's all about finding that natural structure in the data that a human might not see.
Okay, that makes sense. Which brings us to the third type, which always feels the most, futuristic: reinforcement learning.
Yeah, this one is all about trial and error. It's the closest thing to how you train a pet.
Okay, so with rewards and penalties.
Exactly. The machine, or agent, takes an action in an environment. If it's a good action, it gets a reward. If it's a bad one, a penalty.
And its only goal is just to get the most rewards possible over time.
And that's how you get an AI that can beat a grandmaster at chess.
Or, and this is the big one, how a self-driving car learns. Staying in the lane is a reward.
And getting too close to an obstacle is a huge penalty. It's constantly learning, constantly adjusting its strategy to maximize that reward signal. It's incredibly powerful for complex problems.
So if you zoom out, it's pretty clear that ML is this massive toolkit that's really just reshaping everything: healthcare, finance, you name it.
Absolutely. And for anyone listening, professionals in pretty much any field, having a grasp of these three ideas is becoming, essential.
It's not optional anymore. So to leave everyone with a final thought, since reinforcement learning is so good at mastering complex tasks through rewards, what's the most high-level human skill, something like strategic negotiation or even creative problem solving, that you think a system like that will master next?